Yesterday we started talking about combinations and permutations. Combinations and permutations. Permutations, order does matter. When you're dealing with permutations, order does matter. When you deal with combinations, order is unimportant. Okay, it's not important. Up here, order is important, order is not important. You have n number of items. And you're picking or selecting 4 or R number of items. You're selecting R number of items out of N. So we have NPR or NCR. And we talked about yesterday how we can deal with them. My suggestion to you is that you get your hands on a calculator that does this for you. So you're not working through the factorials and getting bogged down with all the factorials. But if you have to utilize a calculator and use all the factorials, you're going to have to do it. Okay? That's the problem you run into. You need to get a calculator that can do that. Once again, it does not have to be a fancy calculator. It doesn't have to be a graphic calculator. You can get a basic TI-30 calculator and be able to calculate this. You don't have to get an extravagant TI-84, 85, 86. On a TI-30, you have a PRB button, and now it allows you to pull down your permutation or combination. Okay? And that's up to you. Okay, the TI-30s, they cost $20 at down there at Walmart, if even that. And at 85 and 86, yes, they cost $85, $90 or $100 down there. But it's a very useful calculator, especially if you're going to advance yourself into the mathematics worlds. Now, when dealing with each one of these problems, you have to determine, is order important or is order not important? And if you look at my solutions, all you need with your solutions is you need to give me the notation, your NPR, NCR there, and you can just do the calculations then. You can go to your calculator and be able to come up with solutions. You don't have to show me what all the mathematics you're doing. Number 5, if we take a look at number 4, in order to conduct an experiment, 4 subjects are selected at random from a group of 20 subjects. How many different ways can the 4 subjects be selected? Okay, just 4 subjects out of 20 are being selected for some sort of experiment. Is this a combination or is this a permutation? Is order important or is order not important? Jordan? I can't hear you. Combination, because order is unimportant. We are choosing 20, out of 20 we're choosing 4. So we have 20C4. And once again, at that point, you can go to your calculator and come up with a solution. I don't need all this. If you want to write it, that's fine. Where we have 20 over, we have 20 minus 4, which is 16 times 4. And we can just write that out. And if you have to use, your factorials, you have to use them. You can get a solution down there, it's fine, but it's going to be a little bit more cumbersome for you. You have 1,485. We go back, number 7. And raffle sold 50 tickets, $10 each. 5 tickets are drawn from the tickets, and each group gets $50. Permutation or combination? Alec? Combination, because order's not important. Each one gets $50. So that would be a combination. So we have 50 tickets, and we're choosing 5. Okay, so I have 50C5. Let me get our solutions once again. Know your calculator, KYC, know your calculator. Okay, be able to find how your calculator works. Once again, some calculators, you have to type in the 50 first, and then you have to go to your math button, and go over to PRB, which is probability, and then choose the option, and that will get you your NCR, and then type in the value of 5. Other calculators, if you go to that math and the PRB, you'll get 2 boxes in the front and back that you can fill in the boxes on the front and back. So it depends on the type of calculator you have in regards to what you will have to do. Problem number 8, 50 tickets sold for $10. First ticket drawn gets 150, second is 100, third is 50, fourth is 25, and the fifth is 10. How many different ways of selecting the 5? This is combination or permutation, Kayla. Number 8. That's a permutation because order now does matter. And number 7, order did not matter. But at 8, order matters. Unless you don't care, if you just say, oh, I won, I don't care how much money I win, just so I win. You don't care. So this will be a permutation. So once again, we have 50, but now we're picking 5 out of the 50. So should they get 254,251,200? Down at the bottom, 9 and 10. Has nothing to do with combination permutations, but it's still counting. If we take a look at 10. A license plate has 1 letter, followed by 2 digits, and then finally 2 letters. Okay, if you haven't done it, you should be doing it. Okay, we have 1 digit, or 1 letter, 2 digits, and then 2 letters. So get your 5 blanks down. Under each blank, is it a letter or a number? Just put L or D for a digit. We have a letter, we have a digit, we have a digit, we have a letter, we have a letter. Now, there's stipulations. The letter O is not allowed because it gets confused with the number 0. Okay, the letter O gets confused with the number 0. So write in the blank. How many letters do you have for the first letter? Now the number 0 is allowed, so how many digits then do you have for the second or for the first digit? And then the next digit, how many do you have? Then you finish out with letter and letter, and the letter O is still not allowed. So how many digits or letters do you have? Go ahead and calculate the number of different license plates that can be made. Check your answers with somebody around you. Filling in the blanks. Tate, what do you have? How many letters?
25.
Then digits.
10.
10, 25, and 25. Okay, this is a combination, or this is counting principle. For every one of these, I can do this 10 ways. And for each one of these ways, I can do another 10 ways. And then for each one of those, I can do another 25 ways. And each one of those, I can do another 25 ways. So Cole, what are we going to have to do with all these values?
Multiply.
Multiply them together. So if we multiply them together, what do you come up with?
1,562,500.
Once again, mathematically, nothing difficult. But you just have to get used to the process of what you have to do in each and every problem. Any other questions you have? Anything else you need me to explain? Once again, mathematically, for the combinations in like number 8, if you have 20p5 there and you just write 254, 251, 200 as a solution, that is fine. But I need to see this right here. I need to see, do I have a permutation or combination? Because if you had the wrong one there, I can at least give you partial credit. But if you just have a number down there, I can't see, well, what'd you do to get that number? So show me it. Do you have a combination? Do you have a permutation? Any other questions? All right, this completes chapter 3. The next 2 days we'll spend doing worksheets on probability. On Friday, we will have an in-class assignment on probability. On Monday, we will have a review day for chapter 3. Tuesday next week, we will have a quiz on chapter 3. The rest of the time is yours to work on these. I have solutions up here. Feel free to have conversation amongst yourself if you need to help each other out. That is fine. Again, you have about 20 minutes here. The rest of the time is yours. Yeah.